Hi, this is Sabir again. In this lecture, I am going to discuss all about the lithostatic stress. That means how we can determine stress at a certain depth or something like that. So today's lecture is all about the lithostatic stress. Lithostatic stress. So before I go, I would like to give you I would like to give you the what is the lithostatic or the lithosphere, something like that. So if this is the earth, say for example this is the earth, then the core part is here is the core, right? And the upper part is called the lithosphere, and this part is called mantle, and this part is called core. So this part is core, and this whole part is called the mantle, and this part is called the lithosphere. The average thickness of the lithosphere is approximately 35 to 40 kilometers. So it varies from region to region or something like that. So we'd like to find how we can calculate stress at a certain depth or something like that, right? So this is all about the lithostatic stress. So we can find the lithostatic stress uh, uh, from the earthquake focal mechanism. Earthquake focal mechanism, so which give us about 15 to 20 kilometer depth stress, something like that, or and to in situ, a geological in situ, or we can find out stress from the GPS or geodetic measurement, surface measurement, GPS or geodetic geodetic measurements. Another way you can find out oil bore or something like that from borehole, which give us about one to say maximum 2 or 3 kilometer stress, 3 kilometer depth stress, something like that. So there are a lot of techniques from where we can find out the stress in the lithosphere or something like that. So this upper part so we know this upper part is lithosphere, right? So we are interested to find out the stress at certain depth here at this regime. Yeah. Okay, let's draw a block here. So this is the block, and so this is the average something block, and this is the mantle depth B, and say for example this is the Y, is the average continental depth. So say for example that density of this continent is rho C, and density of mantle is rho M. So this is mantle, sorry, this is mantle, right? And this is continent, this is continent. So so from there, so we know that at any particular depth the pressure or stress is the pressure or stress is rho times acceleration due to gravity times that particular depth y. So in the stress tensor, so say for example here, if it is x, if it is z, and it is y, that means y is the vertical. So if stress tensor, so we can find out this sigma xx, sigma xy, sigma xz, and sigma yx, sigma yy, and sigma yz, sigma zx, sigma zy, and sigma zz, right? And this is full stress tensor at a particular point or something like that. So sigma yy is the vertical force or vertical force per unit area that acts beneath the earth, right? Sigma yy. If we say sigma y is the vertical direction or something like that, then we can find out the particular depth sigma yy, that force per unit area is equal to rho gy, or stress at a particular depth is here rho gy. So for example, we are interested to find out at depth y, then how we can find out this? So we know the average. So from this equation. Okay, before I go to determine this, so I would love to say something all about the equations. So from this equation, you can conclude two broad things. Here I'm going to give you an overview of that. Say, so uh, this normal force, right? Because sigma y is a vertical direction or vertical positive direction. That means from the surface of the earth, and negative direction. That means from beneath the surface. So this normal force, because definitely this is the normal force. Yeah, this normal force per unit normal force per unit area, because this is the stress. This is the normal force. This normal force per unit area on horizontal planes increases linearly with depth, right? So this increases linearly with depth. So more the depth, because g and rho is constant and only the variable is y, so that means this normal force per unit area varies or proportional to the depth. That means it varies linearly with depth, right? So from this the normal stress due to the weight of overlying rock. That means say here we have a block here. So say zigzag block, there is another block, this is the mantle, say this is the mantle and this is the continent. So the normal stress due to the weight of the overlying rock, say we are interested to find out the stress at this depth, say y. So the normal stress weight of the overlying rock, that means weight of the continents of that, or overburdens, known as the lithostatic stress or pressure, right? So the pressure or stress at any certain depth is nothing but due to the weight of the overlying rock or overburdens, is known as the lithostatic stress or lithostatic pressure, right? So how we can numerically find out this? So say we need to understand the we need to know acceleration due to gravity, and we need to know the average continental or mean continental density and the depth we are interested to find out. Say 35 kilometer is the average crustal depth, average lithostatic or crustal depth. Then we know y equal to average crustal mean average crustal depth. That means y equal to 35 kilometer. That means 3.5 into 10 to the power 4 meter, right? And average continental density is average continental density is 2750 kg meter per cube, and acceleration due to gravity g is so simple, 10 meter per second square, right? So now from this equation, so we can calculate or find out this. So we know the sigma yy rho rho c. So what is that? Rho 2750 into 10 into 3.5 10 to the power 4. Then we get 9.625 into 10 to the power 8 Pascal, because Pascal the SI unit of pressure is Pascal. Or we can write down here 962.5 megapascal. The SI unit of the pressure is Pascal, but here in earth science or geoscience, because pressure is used, that's why we express the pressure or stress here in this earth science community as megapascal. So it's megapascal. For 1 megapascal is 10 to the power 6, right? 1 megapascal equal to 10 to the power 6 pascal, right? Yeah, we know everything. So same way, if the density of density of the mantle is 3300 kg per meter cube, then we can find out the stress at this regime as well. So at any point depth, so something like that, right? So here, why should be B here, right? So B is the depth to the mantle to who is the continent things, right? Yeah. So I hope you have understood the process to find out the stress at any particular depth in this earth. So I hope you enjoyed this. Thank you very much, and I hope I'm going to see you on the next lecture. And do not forget to subscribe to Subject Foundation. Thank you. Thank you very much.